Hello everyone, welcome to the channel Amazing Civil Engineering Studies.
Hello friends, in this video we will study about
Bar Bending Schedule BBS. In this video, we will cover the following topics. Bar Bending Schedule BBS Estimate of Steel in Building Construction. Bar Bending Schedule for Slab Estimation of Steel Reinforcement in Slab. Bar Bending Schedule for Reinforced Concrete Beam. So first we are going to learn about Bar Bending Schedule BBS Estimate of Steel in Building Construction. What is Bar Bending Schedule? In civil engineering, bar bending schedule is the important part of estimation chart. In the bar bending schedule provides the reinforcement, steel, calculation for reinforcement of concrete column beam and slab cutting length, and also used to find the types of bends of length which we provide in steel structures. BBS. The word BBS plays a significant role in any construction of high-rise buildings. BBS is used in finding cutting length of steel and total weight of steel per unit area. And we can make the bar bending schedule in Microsoft Office Excel software. First of all, bar is any type of rebar which is used as a reinforcement in RCC. The bar may be a mild steel bar or HYSD bar or TMT bar. Bar bending schedule is termed as calculation of the total steel required for the construction of a building. We use steel to make concrete to be reinforced and for tension requirements. But how much steel required for constructing 10 floors building? How much steel I have to order? In bar bending schedule, the bars are organized for each structural units, beams or columns or slabs or footings, etc., and detailed list is prepared which specifies the bar location, bar in footings, slabs, beams or columns, bar marking, to identify the bar in accordance with the drawing. Bar size, length of the bar used, quantity, no. Of bars used, cutting length, type of bend and shape of the bar in reinforcement drawings. At initial time we've used only 4 bars in columns. Now we are using 12 plus bars in columns based on load analysis. So, the percentage of steel is increased in a column. Bar bending member. Percentage slab. 1% of total volume of concrete beam. 2% of total volume of concrete column. 2.5% of total volume of concrete footings. 0.8% of total volume of concrete. Here we are with the initial basics of BBS. No. Particulars. Result. 1. Standard length of the steel bar. Bars are sold at standard length 12 m or 40. 2. Weight of bar for length equals 1 m. D. 2/162. Where D equals dia of bar. X. If length of bar is 12 m with 10 mm diameter, then weight of bar equals D. 2/162. Therefore for length 1 m equals 1 m x d. 2/162 equals 1x10. 2/162 equals 0.61 kgs. For length 12m equals 12x10. 2/162 equals 7.40 kgs. 7.40 kgs. 3. Density of steel 7,850 kilograms m. 3. Here, we are going to see different concepts of bar bending schedule which are very useful while working with BBS. All these concepts are used in BBS design calculation of any structural member. 1. Hook length or cutting length of stirrups. The hook length is commonly provided for stirrups in beams and ties in columns. In general, hooks are added at the two ends of the rebar in stirrups or ties. Hook length equals 9d, d is diameter of the bar. Below image makes you clear why the hook length equals 9d. Length of hook equals, curved portion, plus 4d equals, 4d plus d, plus 4d equals 9d. Example calculation considering stirrup with the hooks at ends. Look at the below image for calculation of the total length of stirrup with two hooks at ends. Total cutting length of stirrup or tie equals total length of bar plus 2x hook length, 2 hooks. Total cutting length equals L plus 2, 9d. Therefore total cutting length equals L plus 18d, d is the diameter of a bar. Hope, now you are clear with the hook length calculation. 2. Bend length. The bend length calculation is different for cranked bars, bent up bars, and bends at corners. The bars are usually cranked in slabs and bars are bent at corners in stirrups or ties. Bend length calculation in cranked bars. As shear stress is maximum at supports in slab. To resist these stresses we usually crank the bars at the ends of supports in the slab. The below figure depicts the bent up bar in slab. To calculate the bend length the below procedure is followed. From the above figure as the bar is bent at an angle θ0 the additional length, L A, is introduced, where L A equals L 1 L 2. Equation 110 equals d/L 2. Sin equals d/L 1. Hence L 1 equals d/sin and L 2 equals d/10. Therefore from equation 1 L A equals d/sin d/10, giving different theta values as 300, 400, and 50,600 results different additional length L A values as below. Different theta values. The additional length is added to the total length of the bar if the bars are cranked at a certain angle. theta 0. D slash sin D slash tan L. A equals D slash sin D slash tan 300 D slash 0.500 D slash 0.573 0.27 D 450 D slash 0.707 D slash 1.000 0.42 D 600 D slash 0.866 D slash 1.732 0.58 D 900 D slash 1 0 1 D 1350 D slash 0.707 D slash 1 2.42 D. Example calculation considering bent-up bar in slab, cranked bar to keep the crank bar in position, an extra bar of length, L/4, is provided below the crank bar as shown in the below figure. Therefore, the total length of bar equals L plus 0.42 D plus 0.42 D plus L/4 plus L/4 equals 1.5 L plus 0.84 D. Remember D equals depth of slab top cover bottom cover. Bend length calculation when bars are bent at corners. The important standards used while calculating the bend length at corners. 45-degree bend length equals 1 D. 90-degree bend length equals 2 D. 135-degree bend length equals 3 D. Here, D equals diameter of bar. Example calculation considering stirrup with the bends at corners. From figure, there are 3 bends which are bent at an angle of 900 and 2 bends are bent at an angle of 1350. Total bend length equals 3x 900 bend length plus 2x 1350 bend length equals 3x 2d plus 2x 3d equals 1 2d equals 12x 8 equals 96 mm. Below table represents the total length of bar calculation for different types of bar shapes. Bar shapes. Total length of hooks. Total bend length. Total length of bar. Straight bar. 2 hooks. Equals 9D plus 9D. Equals 18D. No bend. L plus 18D. Bent up at one end only. 2 hooks. Equals 9D plus 9D. Equals 18D. 1 bend bent at an angle 45. Equals 0.42D. L plus 18D plus 0.42D. Table continue. Bar shapes. Total length of hooks. Total bend length. Total length of bar. Double bent up bar. 2 hooks. Equals 9D plus 9D. Equals 18D. 2 bends bent at an angle 45. 0. L plus 18D plus 0.42D plus 0.42D equals L plus 18D plus 0.84D. Overlap of bars. 2 hooks equals 9D plus 9D equals 18D. No bends. Overlap length equals 40D to 45D plus 18D. 3 overlap length in reinforcement. The standard length of rebar is 12 m. Suppose the height of the column is 20 m. To purvey this requirement, 2 bars of length 12 m and 8 m are overlapped, joined, with overlap length. Overlap length for compression members, columns, equals 50D. The overlap length for tension members, beams, equals 40D. D is the diameter of the bar. Have you seen the below picture on your top floor of the building? We generally project some length of bar on the last floor, i.e., 50D. It is used for further construction purpose, constructing a new floor. How to prepare bar bending schedule. To understand clear, here I am considering the below structural member RCC column and preparing abs for it. BBS of column. Structural member column. 3mx 0.3mx 0.3m. Bar marking. 1 main bars. 2 stirrups, longitudinal bars. Diameter of bar. 1 main bars equals 16 mm. 2 stirrups. Longitudinal bars, equals 8 mm. No of bars used. 1 main bars equals 4. 2 stirrups equals 30. Cutting length. 1 main bars equals 3.16 m. 2 stirrups equals 2.64 m. Total length of BAR1. Main bars equals 18.4 m. 2 stirrups equals 43.2 m. Weight of steel BAR1. Main bars equals 29 kgs. 2 stirrups equals 17 kgs. Calculation part of above table. No of bars calculation. Main bars equals 4. To calculate the no of longitudinal bars, adopt spacing between bars is 0.1 meter. No of longitudinal bars equals length of column spacing equals 3/0.1 equals 30 billion Argentine pesos. Longitudinal bars equals 30. Cutting length calculation. Main bars equals 3m plus 50d plus 50d equals 3 plus 50 times 0.016 plus 50 times 0.016 equals 4.6 m. Stirrups. Hook length equals 9d plus 9d equals 18d equals 18 times 0.08 equals 1.44 m. Bend length equals 3x900 bend length plus 2x1350 bend length equals 3x2d plus 2x3d equals 12d equals 12x8 equals 0.096 m equals L plus hook length plus bend length equals 0.3 plus 0.3 plus 0.3 plus 0.3 plus 0.144 plus 0.096 equals 1.44 meter. Hence for main bars equals 4.6 meter, longitudinal bars equals 1.44 meter. Total length of bars. Total length of main bars equals number of main bars x length of one bar. Equals 4x 4.6 equals 18.4 meter. Total length of longitudinal bars equals no of longitudinal bars x length of one bar. Equals 30 times 1.44 equals 43.2 meter. Weight of steel bar. Weight of steel bar for 1 meter equals 1 meter xd2/162. Total weight of main bars equals 18.4 x 162/162 equals 29 kgs. Total weight of longitudinal bars equals 43.2 x 82/162 equals 17 kgs. Total weight of steel bar required to do BBS of above column equals 46 kgs. Important rules while preparing bar bending schedule. The bars used in building should be grouped together for each structural unit and listed separately for each floor. Bars are listed in numerical order. To identify the bar in the bundle of bars, each bar is uniquely labeled with reference details: length of the bar, size of the bar, shape of the bar. The type of bar and shape of the bar should be in accordance with B8666. It is essential that the bar mark reference on the label attached to a bundle of bars refers uniquely to a particular group or set of bars of defined length, size, shape, and type used on the job. The cutting length and bending length calculations are separately calculated and not included in the detailed list. Like I have listed the bar bending details in a table and calculations are done separately. Use of bar bending schedule. BBS helps to estimate the total quantity of steel required for the construction of building or structure. It helps to quote for tender the cost incurred by steel. Finding the cutting length and bending length in reinforcement detailing improves the quality of construction and minimize the wastage of steel, makes an economic construction. With the help of reinforcement drawings, cutting and bending can be done at the factory and transported to the site. This increases faster construction and reduces the total construction cost. For site engineers, it becomes easy to verify the cutting length and bending length of the reinforcement before placing the concrete. Bar bending schedule for slab. Estimation of steel reinforcement in slab. Bar bending schedule for slab. There are 16 different types of slabs in construction. Well, the thickness of slab generally varies between 4 to 8. We generally adopt 6, 0.15 m, slab thickness. For occasionally heavy loads we adopt 8 and above thickness slabs. Quantity of reinforcement, steel, required for slab or bar bending schedule for slab. Primarily slabs are classified into two types: one-way slab and two-way slab. In one-way slab, main bars are provided in shorter direction, cranked bars, and distribution bars are provided in longer direction, straight bars. Whereas in two-way slab main bars, cranked bars, are provided in both directions. Usually, the two-way slab is adopted when the length and width of the slab is more than 4 m. Main bars and distribution bars are provided in the one-way slab. In two-way slab, distribution bars are provided in both sides of slab. Here we are going to consider a one-way slab and two-way slab as shown in the figure. Distribution bars, these bars are straight bars. Main bars, these bars are cranked bars. Main bars are cranked at an angle of 45 degrees with the length of 0.42 d, where d equals depth of slab top cover bottom cover. Extra bars, the extra bar is provided at the bottom of cranked bars to maintain the framework of the slab. The length of extra bar is L/4. Steps to calculate the reinforcement required for slab. Deduct the cover for finding length of bar. Evaluate the length of the distribution bar. Calculate the value of d, depth of slab top cover bottom cover. Find out the no of bars. Compute the total weight of steel required for slab reinforcement. Consider, diameter of bars equals 10 mm, spacing between bars equals 0.10 m, depth of slab equals 0.15 m, floor slab 1, two-way slab bars along x-axis. Deduction of cover for this: divide the beam into two parts with axis line. From the figure, breadth and depth is 0.4 times 0.4. Length of distribution bar equals bar length center to center deduction of cover, both side, plus 0.42 d times 2. Equals 4.20.025 minus 0.025 plus 0.42 d times 2d equals depth of slab top cover bottom cover. Depth of slab equals 0.15 meter. As per condition for 0.15 meter, cover of 0.025 meter is provided from top and bottom. Therefore, d equals 0.15, 0.025, 0.025 equals 0.1 meter. Length of distribution bar equals 4.20.025, 0.025 plus 0.42 times 0.1 times 2 equals 4.234 meter. Numbers of bars equals opposite length spacing, plus 1 equals 3.8/0.1, plus 1 equals 39 billion Argentine pesos. Extra bar length equals L/4 equals 4.154 equals 1.0375 meter. For each bar, 2 extra bars are provided. Therefore, length of extra bar for 1 bar equals 1.0375 times 2 equals 2.075. Total length of distribution bars equals 39 times 4.234 plus length of extra bar equals 165.126 meter plus 39 billion Argentine pesos times 2.075 equals 246.051 meter. Weight of steel bar in kilogram per meter equals D2/165 for 10 mm bars equals 10 to 165 equals 0.61 kgsm, kilogram per meter. Total weight of steel equals 0.61 times 246.051 equals 150.091 kgs. Bars along y-axis. Deduction of cover for this: divide the beam into two parts with axis line. From the figure, breadth and depth is 0.4 times 0.4. Length of distribution bar equals bar length center to center deduction of cover, both side, plus 0.42 d times 2 equals 4.20.025 minus 0.025 plus 0.42 d times 2d equals depth of slab top cover bottom cover. Depth of slab equals 0.15 meter.
In this side I go
as
to ribbon.
Per condition for 0.15 meter
tabs,
cover of 0.025 meter is provided from top and bottom.
Right? In my case I already have it, so it doesn't make
Therefore,
sense. So basically
D
again,
equals 0.15, 0.025, 0.025 equals 0.1 meter. Length of distribution bar equals 4.00.025, 0.025 plus 0.42 times 0.1 times 2 equals 4.034 meter. Numbers of bars equals, opposite length spacing, plus 1 equals, 4/0.1, plus 1 equals 41 billion Argentine pesos. Extra bar length equals L/4 equals 3.954 equals 0.9875 meter. For each bar 2 extra bars are provided. Therefore, length of extra bar for 1 bar equals 0.9875 times 2 equals 2.075. Total length of distribution bars equals 41 times 4.034 plus length of extra bar equals 165.394 meter plus 41 billion Argentine pesos times 1.975 equals 246.369 meter. Weight of steel bar in kilogram per meter equals D2/165 for 10 mm bars equals 10 to 165 equals 0.61 kgsm, kilogram per meter. Total weight of steel equals 0.61 times 246.369 equals 150.285 kgs. Total weight of bars equals 150.285 plus 150.091 equals 300.376 kgs. Bar bending schedule for reinforced concrete beam. Bar bending schedule provides the reinforcement calculation for reinforced concrete beam. It provides details of reinforcement cutting length, type of bends and bend length. Example for reinforcement quantity calculations for a concrete beam. Consider a beam of clear length of 4 m, 300 mm wide by 450 mm depth. It consists of 212 diameter bars at top, and 2 to 16 diameter and 112 diameter bars at the bottom. Diameter of stirrup is 8 mm spaced at 180 mm center to center. Clear cover to reinforcement provided is 40 mm. Now we will calculate the length of reinforcement based on shapes of reinforcement required for reinforced concrete beam in above example. We will start with bottom reinforcement, B1. Bar shape of B1 is as shown in figure. Length of B1 equals clear distance between walls plus 2x width of walls 2x bar cover plus 2x bend length. Bend length equals 6x 16 equals 96. Consider as 100 mm bend length is calculated as 6x diameter of bar for reinforcement conforming to IS 1786 to 1961. Length of B1 equals 4000 plus 2x 230 2x 40 plus 2x 100 equals 4580 mm. Length of bar B2 is calculated based on shape of this bar. This bar bends up near the support as shown below. Length of bar B2, A plus B plus C equals 4000 plus 2x 230 2x 40 plus 1.414 xHH. H equals 450 2x 40 2x 12 2x 12/2 equals 334 mm. B2 equals 4000 plus 2x 230 2x 40 plus 1.414 times 334 equals 4518.3 equals 4520 mm. Length of bar T1 equals 4000 plus 2x 230 2x 40 equals 4380 mm. Length of stirrups S1. Stirrups are spaced at 180 mm center to center. Stirrups are provided between walls or support for a beam. No of stirrups required for given beam equals no of stirrups. Length A equals 452 x 48 equals 362 mm. Length B equals 302 x 48 equals 212 mm. Therefore, length of one stirrup S1 equals 2x 212 plus 362 plus 90 equals 1328 mm, where 90 mm is the minimum hook length as per IS 2502 table. 2. Bar bending schedule for RCC beam. No. Bar mark. Bar dia. No of bars. Length. Weight of bars, kg. Bar shape. 1B1. 16. 2. 4580. 14.5. 2B2. 12. 1. 4520. 4.02. 3T1. 12. 2. 4380. 7.80. 4S1. 8. 24. 1330. 12.6. Advantages of bar bending schedule. Bar bending schedule provides details of reinforcement cutting and bending length. Advantages of bar bending schedule is when used along with reinforcement detailed drawing improves the quality of construction cost and time saving for concrete construction works. Advantages of bar bending schedule in concrete construction are: when bar bending schedule is available, cutting and bending of reinforcement can be done at factory and transported to site. This increases faster execution at site and reduces construction time and cost due to less requirement of workers for bar bending. Bar bending also avoids the wastage of steel reinforcement, 5 to 10%, and thus saves project cost. Using bar bending schedule for when used for FE500, it saves 10% more steel reinforcement compared to FE415. It improves the quality control at site as reinforcement is provided as per bar bending schedule, which is prepared using the provisions of respective detailing standard codes. It provides the better estimation of reinforcement steel requirement for each and every structural member, which can be used to compute overall reinforcement requirement for entire project. It provides better stock management for reinforcement. Steel requirement for next phase of construction can be estimated with accuracy and procurement can be done. This prevents stocking of extra steel reinforcement at site for longer time, preventing corrosion of reinforcement in case of coastal areas. It also prevents shortage of reinforcement for ongoing work by accurate estimation, and thus concrete construction works can proceed smoothly. Bar bending schedule is very much useful during auditing of reinforcement and provides checks on theft and pilferage. Bar bending schedule can be used for reinforcement cutting, bending, and making skeleton of structural member before it can be placed at the required position. Other activities such as excavation, PCC, etc. can proceed parallel with this activity. So, overall project activity management becomes easy and reduces time of construction. It becomes helpful in preventing any damages due to construction time overrun. It provides benchmarks for quantity and quality requirements for reinforcement and concrete works. Bar bending schedule provides the steel quantity requirement much accurately and thus provides an option to optimize the design in case of cost overrun. It becomes easy for site engineers to verify and approve the bar bending and cutting length during inspection before placement of concrete with the use of bar bending schedule, and helps in better quality control. It enables easy and fast preparation of bills of construction works for clients and contractors. The quantity of reinforcement to be used is calculated using engineering formulas and standard codes, so there is no option for approximate estimation of steel reinforcement. With the use of bar bending schedule, mechanization of cutting and bending of reinforcement can be done, again reducing the cost and time of project and dependency on skilled labor requirement. It also improves the reliability on accuracy of bar cutting and bending. When mechanized bar cutting and bending is used, the cost of reinforced concrete work per unit reduces and helps in cost optimization of construction project. Thanks for watching. For now, please subscribe, like, share and do not forget to press bell icon.